All right, let's take a look at Chapter 5, review number 3. Find the first and second derivative. So let's go ahead. Y prime equals 3x squared minus 4x plus 1. Y double prime equals 6x minus 4. All right, find the first and second derivative. Use them to find the maxima, minima on the interval 0 to 4. So, to find extrema, we set our first derivative equal to 0. Let's go ahead and solve that guy. Let's call it, go ahead and factor 3x minus 1, x minus 1, x equals 1/3, x equals 1. So those are our extrema. Both are within the bounds of 0 to 4. So we'll include checking those with our function. Now, we could show the first derivative test with these guys. But let's also use the second derivative to discuss concavity and say how that can show us what our extreme points are. So 6x minus 4 equals 0, so x equals 2/3. That means we have one change in concavity at 2/3. So let's look at the second derivative test at 2/3. Before 2/3, so let's put a number like 0 into our second derivative. If I put a 0 in, I get a negative number, which means we are concave down. If I put a number like 1 or 2 or 3, any number greater than 2/3 in, I get a positive number, which means we are concave up. So before 2/3, we are concave down. Therefore, x equals 1/3 must be a local maximum. After 2/3, we're concave up, so x equals 1 is going to be our local minimum. The whole key to this problem, I feel, is that they asked us to discuss the interval from 0 to 4. Therefore, we need to discuss f of 0, f of 1/3, f of 1, and also f of 4 to find our maximum and minima on the interval. So all those numbers should go into our original function. So plugging those into my table, I get f of 0 is negative 1, f of 1/3 is negative 0.851, f of 1 is negative 1, and f of 4 is 35. So, discussing max and mins, this actually is a local max. This is our absolute max. And then both of these would be minimums, local or absolute.